right, guys, before we get started, are there questions over the homework? Question over the homework, guys. Question over the homework. All right, guys, let's focus in here. What we're doing today is solving inequality exponential equations. So solving these here, these inequalities, exponential inequalities, is no different than solving equations. So when we look at this first one here, we have 3 to the x is less than 20. Now when we had it as an equation, 3 to the x is equal to 20. To get the x out of the exponent, we would apply log base 3 to both sides. And the same thing's true with our inequalities. And on the left side, log base 3 of 3 to the x would reduce to x. And it's telling us it's less than log base 3 of 20. And yes, we could put log base 3 of 20 in the calculator, but here, well, yes, we can put that in there. And if it is a nice number here, it's not, because if it was, we could have rewrote 20 as 3 to a power, and it'd work out. That's it. Because the only other step that we would do after that is take log base 3 of 20, see what its value is, and then just replace it to 3 decimals. Now, looking at this here, now we will come across some different properties to it, like we had yesterday when we were solving the logs, how what's inside the logarithm can't be 0 or negative. Exponentials, there is no restrictions on that. Because here, the x in the original problem is in an exponent. I can put a negative number, I can put a positive number, we can put fraction, decimal, radical. I can put whatever I want in that radical, or not radical, but that exponent, and it works out fine. There is no issue with that. The only one we come across that might be an issue is I. Not really, we can still do that, but we're not even talking about those. But in the real number system, I can put whatever number I want there, and it's going to work. So there are no restrictions on this here. Because if we look at the next one, e to the x is less than 2. E to the x is less than 2. And this time we're going to apply what log to both sides? ln. Because our ln of e to the x is less than ln of 2. That's it. And again, I'm not going to, especially on the test, I'm not going to make you type the natural log of 2 in and around the 3 decimal places. Because again, that's not your ability to solve this inequality. It's just your ability to type it in a calculator. And it's going to save y'all some time on the test, not having to type all this stuff in. So we have 10 to the 2x minus 6 is greater than 3. What would we do first? So we do log base 10, which is actually just the same as log, because we don't have to write the base 10, it's understood. On the left side, our log base 10 to the 2x minus 6 is just 2x minus 6. It's greater than log of 3. Well, this is the first one where x is not immediately by itself, but we need to get it there. So the next thing we would do is add 6 to both sides, telling us that 2x is greater than log base 10 of 3 plus 6, or log of 3 plus 6. And lastly, we would divide by 2. So x is greater than log of 3 plus 6 all over 2. Now again, you do need to be careful with multiplication and division with inequalities. And that's if we multiply or divide by negative. If we multiply or divide by negative, we have to change that sign. We have to flip it from greater than to less than, or less than to greater than. But that's it for this here. Questions on this so far? Questions on anything we've done so far? Okay. Our next one that we have is log of x is less than or equal to 2. What do we do first? Put both sides to almost to the base of 10. Because the base inside the log is 10, so we put it to that base, because 10 to the log of x, 10 to the log base, 10 of x, this here will cancel, leaving x by itself. Telling us that x is less than or equal to 10 to the second power. Well, what is 10 to the second power? 100. So x is less than or equal to 100. Now, as I said with exponentials, when the variable starts in the exponent, we can have whatever we want. If we start with a log, we have to be careful. Because here it says we can have any value of x that is less than or equal to 100, yes? Here, I'm going to just pick one. Let's just say x is negative 7. Does that satisfy this inequality down here? That x is less than or equal to 100, yes? So it's saying that log of negative 7 is less than or equal to 2. Yes? What is log of negative 7? Domain error. Because what did we say yesterday? That what's inside the log cannot be negative or 0. Yes? But this statement down here included negatives and zeros. Yes? So what we have to do, and normally what I do with some of these here, I'll write this out as we start. Erase that. Is we take a look at what's inside the log. Here is x. Well, we know x has to be greater than 0. We set that statement up. What's inside the log? Greater than 0. Solve for x. Well, we're done for this one here. X has to be greater than 0, yes? If our final answer when solving the actual equation, here where we got x is less than or equal to 100, it includes those negatives, it includes those restrictions. We have to take this here and add it onto it, telling us that 0 is less than x is less than or equal to 100. Anything greater than 0 all the way up to and equal to 100 works. So we kind of cap it off so we remove those restrictions from it. Because now negative 7 doesn't work. Because negative 7 is not true for our inequality down here. Does that make sense? We have to go back and remove any value of x that would make we need to remove it. Yep. We've got to remove it out. Here. Yeah. So for here, because it was just x, it has to be greater than 0. We'll look at a few more, some that have that, where it's not just 0. And some where it may not come into play at all. Now this one here, I don't like. Yeah, okay. Yeah. So looking at this here, what is inside the log? X. We would have to subtract 9. If it was x log of the quantity x plus 9, there would be parentheses. Because there are no parentheses, just the x is inside the log, the plus 9 is out. and this is the correct notation to write this, but if x plus 9 was inside the logarithm, they would specifically put the parentheses. I'm not as big of a fan of it. I'd rather have it specifically stated what is and what isn't, not assuming we know the terminology. But we'll look at this in two cases because I do want to see that other one. But if we're going to solve this, the first thing we need to do is get the log by itself. And we'd subtract 9, which would tell us that log of x is less than 45 minus 9, which is 36. One more time. Oh, when we need to actually calculate it, a value, if it gives us a nice number. So 10 squared is a nice number. As those that we can calculate nicely that actually work out to a nice number. And if you're not sure, because on the last one, 10 squared, we got this nice number. I think the one before, say, log of 7. You type it in, and we get this ugly decimal. It's not going to work. So log of 3 plus 6, because log of, well, let's see here, log of 3 plus 6 is this here. Logs, L-O-G, just log, if whatever's inside of it is some power of 10, so 10, 100, 1,000, 10,000, or the fractional version, will work out to a nice number because it's just, that's how they work with our properties. Natural log, unless it's e to a power, they're not going to give us a nice number no matter what. E to any exponent is not going to give us a nice number. So, for the most part, if it's a number to a power, a number power, simplify it. And on the review sheet, because when we get that, I went through and I gave you, if it gives you a nice number, it means it worked out. If I gave you it in log, in E, those there, it means we're stopping. Now, this one here, we are not going to simplify for the most part, and there's a reason why. Because we have log of x is less than 36, yes? What's our next step? We put both sides to the base of 10, yes? They cancel. X is less than, so we have 10 to the 36, yes? Number to a power, so I can say 10 to the 36 is 1 times 10 to the 36. Maybe the other calculator will give us a better number. It'll give us the same thing. 10 to 36. Yeah, same thing. So this one here will leave us this. Partially because yep. So that's what it's really saying. So that there is, it's still a quote unquote nice number. It's just too big. It just got too big. It means it continues on forever, but that makes it, yep, this stops, yeah. So we have this here. Now again, we didn't do the restriction. 36. Now we also said what's inside the log has to be greater than 0 because it's just x. Well, x is indeed less than this 10 to the 36, so we would have to add it on, giving us this here as our answer. Does that make sense? Or this here. Yeah. Yeah, I think it depends on, I think it's probably undecillion, but it's a big number. Yeah, or one, unicycle UN is normally one uni. Dec is 10, so it's 110, 1 in 10. Because if you remember dodecagon, do, 2, dec is 10. Undec is kind of what it is. Yeah, it's weird, but we normally don't get that big of numbers. And we don't have a concept of a number that big. We've only, in the last decade or so, wrapped our head around what a trillion is. And even that's kind of a vague notion. It is a big number. Do we feel pretty comfortable with these so far? Yes? Now, I'm going to alter this one a bit. I want to put the x minus 1 inside the parentheses. That way we do have some restrictions where it's not just x is greater than 0. So here, I didn't do it on the last one. Here, we're going to start with it and say that x minus 1 has to be greater than 0. Even though it's a natural log, what's inside that log has to be greater than 0. Well, since x is not by itself, we would add 1 to both sides, telling us x has to be greater than 1. That's just a minimum. It has to be greater than 1. Now, there can be some cases where the restrictions never show up, because it could be if solving that or trying to get that, we have imaginary, those type solutions, then it's thrown out. But x has to be greater than 1. All right. First thing we can do here, 2 ln of x minus 1. We need to get the natural log by itself first. And we can do that by dividing both sides by 2. Telling us that the natural log of x minus 1 is greater than 2. What would we do next? Put both sides to the base of e. On the left side, the ln, e to the ln, will simplify out, leaving us with x minus 1 is greater than e squared. E, irrational, it's going to stay there. Because we could convert it to a decimal number, but I say let's leave it. And the last thing we need to do is add 1, telling us that x is greater than e squared plus 1. So we have this here, yes? What was our restriction we had at the beginning? That x had to be greater than what? E squared plus 1 is greater than 1, yes? Do I need the other part? No, because those values of x that would make what's inside the natural log be 0 or negative aren't even included in our solution set. We don't even have to think about them. Does that make sense? Yeah. Questions on anything we've done so far? We're going to do this one here, and then we're actually going to be done for the day. Because I've looked at the others, we're not even going to look at most of them, especially the logs, because it's not that they're difficult, it's not that they're challenging, they're not going to show up on the test, and they just throw, I think I'm worried it's going to confuse you more than it's going to help you see other types. Almost. Minus 3 first. You can tell us 5e, the x squared plus 4 is less than 300. Divide by 5 first. We want to get this as simplified as far as we possibly can. We want to really get that base that has the variable in the exponent by itself first. Because once we get it by itself first, here, now we can apply ln to both sides. Because the left-hand side, ln of e to the x squared plus 4 is x squared plus 4. Is less than the natural log of 60. The natural log of any number besides e is not going to be a nice number. It's just going to be a decimal. Now, yes. Now we had ln. Why not? If we were doing this, I wouldn't put one like this, especially on the test. If it had been x squared plus 4x, kind of, we didn't quite see it yesterday. We could have moved the ln over and used quadratic formula. Because the natural log of 60 is a number. It's not written as we're used to seeing, but it is still a number. Because x squared is less than the natural log of 60 minus 4. Natural log of 60 minus 4 is a set number. It's a set value. It's not like a variable that changes. It is a set value. So we can square root both sides. There's nothing wrong with that. Now the square root of x squared is x is less than the square root of the natural log of 60 minus 4. Yes? But what did we normally do when we square rooted both sides? We had to add the plus or minus, yes? Because we're saying that the square root of both sides, square root of x squared is indeed x. But the square root of our natural log of 60 minus 4 is the positive case, but we also have the negative case. This is part of the reason, this is the only one that we'll do of this type because of these kind of quirks that show up because of square root, or not square, taking the square root of both sides and these other properties. That's why I don't want to do too many of them. So that is the answer. Because it started out as an exponent, both of these actually work. Both of these are the solution to it. As funny as that is. And the others that we have in the rest of the packet do delve into these. They won't show up on the test, not like this, because it's remembering the fact that when we square root both sides, we have the positive negative case. Because we're talking about inequalities, anytime we apply a negative throughout with multiplication or division, we have to flip the sign. That's why we have that sign change and working with those there. Again, I added those in for a little bit extra so we can see the different properties, but I'm not going to focus on it. I'm probably going to remove them because they're more hassle than they're worth. Both of those are indeed the answer. So five x squared, I think it was plus 4, wasn't it? Minus 4. You're good? The answer was minus 4. Now I'm moving everything to the same side. That's why it's minus 300. So we get this kind of shape here. Now, if we look at the function just as it was, plus 3, it doesn't show up at all. It's just the numbers are that big. So we get a kind of a U-shaped graph to it. Yeah, actually. Yes. Yes. Beside the point of kind of what the graph looks like. But that's actually it. So that little bit with looking at the graph was more of a tangent, looking into kind of what the graph looks like and how that works. But these are the ones we have here, 47 through 52. If you notice, most of these here are not any more complicated than what we did. the ones on the left, geometry.